In this video, we'll load some example data in Elasticsearch. In this video, I'm going to introduce documents and indices, the plural of index. We'll look at the indexing API. We'll build a Python script that can install or put in new data into our Elasticsearch cluster. And then we'll use Kibana to visualize the data that we inserted. Documents and indices. So when you put data into Elasticsearch, each piece of data or grouping of data you put in there is called a document. If you think about a syslog entry or, a NetFlow record or a audit log or, you can even go to a information about a book or a movie. That group of data is called a document. So let's imagine we have a document to talk about a movie. So we can think about the movie Avatar. We can have a name attribute of this document. The name value would be Avatar. We could have a year released attribute. The value could be 2009 or 2010, whenever Avatar came out. We could have a writer attribute, Steven Spielberg, or whoever wrote it. Those are the attributes, and each attribute has a value. Elasticsearch really likes documents when they come in the JSON format. JSON is the JavaScript object notation format. I have a quick example here showing a key with a value, then an integer key with the value of 9. So I'm showing here that we can have a couple of different data types, strings and integers or numbers or floats, booleans for true, false, etc. When we put those documents in Elasticsearch, they're going to have a type. So the type we talked about with the movie Avatar, the type would probably be movie. We could have other types, car, if we want to talk about cars and the size of their engine and how many wheels they have. Syslog data could be another type if we're loading data from Unix or Linux as syslog. We can have an Apache data type if we wanted to. So once we start putting in all those documents, we can group documents together in an index. Elasticsearch can have tons of indices. Indice is the plural for index in the Elasticsearch world. Depending on the type of data, though, we're going to want to name those appropriately. So if we have a list of movies or if we have thousands of movies in a index, we would probably call that index movies. If we had car information, we probably call the index cars. One of the things, though, that Elasticsearch is really good at is keeping data over time. So if you think about logs from Apache, Apache being a web server, if you want to keep track of all those logs over time, you probably want to have one index per day. Maybe one index per month if it's very few pieces of data, but typically you'll do it by a day. So the example I have here is 2001-10-30-logstash. That's signifying the year of 2001, and in the US, a month of 10 with a date of 30. So this would be 2001, October 30th, logstash. We could have that dash Apache. We could have that dash cars if we're doing some sort of car event logging. But this is really good for events and not just kind of lookup or metadata. But if we wanted to do an index for lookup data, like I said, we could have something called cars, movies, or the example here, website products, where if we wanted to back a search engine or build a search engine that's backing a website, we could use a lookup data kind of index. One thing that Elasticsearch is extremely good at is documenting and providing APIs, application programmer interfaces, to allow you to interact with Elasticsearch. Primarily, you're going to put in data, you're going to query data, you're going to create indices, or you're going to look at statuses of the cluster. There are so many APIs out there. They're really well documented at the Elasticsearch website. So I highly recommend, once you get familiar with the Elastic Stack and Elasticsearch in particular, to take time reading those API documents. It'll be really helpful. But for what we're going to talk about today, we're going to be loading in data to Elasticsearch. So we're going to look at the way we index documents. There are two primary ways. So whenever any document goes into Elasticsearch, each document gets a unique identifier or a unique key for that document. So in this first URL we're building, it's HTTP, the host of Elasticsearch, the port, which is typically 9200, the index name / the type of the document, like we talked about cars or logs or something like that, and then an ID. So you can provide 1, 2, 3, 4. You can use GUIDs, you can use whatever you want to use there, and you can then update that document over time if it's a known ID. If you don't want a known ID, though, in the case of like a syslog message, it doesn't really matter what the ID is over time. You can use the HTTP post method without an ID field to allow Elasticsearch just to generate some random GUID. And then it'll have that so it can keep track of it. So what we're going to do now is look at a little Python code. I have the framework of an application that is going to create some log type data that we're going to put into Elasticsearch. Right now, it's going to basically take 2 days worth of data, fake it out for us using some random attributes. And one thing I want to do is make sure we add some randomness in here so we can simulate kind of a CPU load or something like that. So let's see. Here's our Elasticsearch box that we're going to run the code on. I have it already started out in a function called createFakeData. And you can see in here that we are going to create some fake data over a time range. So as I'm recording this, today is 23rd, 2003. We're going to go backwards for, 60 minutes per hour. 48 hours is 2 days. So we're going to go back 2 days worth of time, simulating an event per minute. So we're going to create this index here called with the date range. So this will be a single day per index with the name fake. So it'll be the date/fake. Oh, and I have a fake type as well. So this is going to have the same document on every day. It's going to have a user field, fowie.com. The post date will be the ISO format of this date time that's created. So it'll be the minute that it's installed. We'll have a message that's just a random bunch of strings, and then I'm just going to have this counter on here. One other thing that I want to do, though, is put in another field to kind of simulate a CPU usage, and then we'll make one for disk usage. So basically I want to create random numbers between 0 and 100 so we can simulate that percentage. So what we're going to do, we're going to make sure we have this random. So doing a little Python code. I'm kind of abstracting this and doing it quickly. You don't need to know Python to get through this, but hopefully you can kind of understand what's going on. So I'm going to add a new attribute. Let's call it CPU for CPU utilization. And I'm going to do a random integer between 0 and 100 to simulate percentage use. And we'll do the same thing for I/O, which in the real world could be something like disk utilization or whatnot. So each of our documents will have its own random number between 0 and 100 representing percentage. So this, again, we'll do a quick code review of this. We'll start today, and then we will add some data. I want to start yesterday to add data for today because I'm adding time here, if you can see this. So my start date is going to be yesterday. We're going to add 1 minute every time. We're going to add 1 minute, then add 2 minutes, etc. to get through today. And then we'll use the HTTP post method to index this document within Elasticsearch. Using this Python requests library, we pass in a URL, which is the Elasticsearch Index API. And then we're going to pass in a JSON body. So this is a shortcut within the post function that takes whatever object this is, this doc. It's a Python dictionary for short. It's got a bunch of key value pairs. And it's going to make it a JSON string when it passes it to Elasticsearch. We're going to get the response and we're going to print out the text. You're going to see this scroll by really, really quickly. And that's okay. So let's run this. Create fake data. Start here. And if you can see this, once this stops, I'll show you what everything means. All right, now that we're done, you can see what happened. Let's pick one of these lines and show you what happened. So on our 2879th document, it went into index 2017 11-23.fake. It was a document type of fake. And here's the ID that Elasticsearch generated, YBSV, etc. Version 1, so Elasticsearch does keep versions. If we took this ID, we could update this version if we want to change some of the documentation. And it's going to say it created the document, made 2 shards for it, it was successful, nothing failed, etc. So now we have data loaded. Let's go back to our Kibana. And first I want to show you some monitoring and see what happened. So we can look at our indices. Let's hide the system indices. And now look, we have 2 of these indexes or indices. One for yesterday. They each have 1.4 thousand documents in them. Here's data size. And shards and status we'll talk more about when we get into clustering Elasticsearch, but for now this should be good. We can do an overview of our Elasticsearch, and you can see we did a lot of indexing at this one point in time. And it looks like we peaked just shy of 100 documents per second, which is really slow for Elasticsearch, and we'll get into speed and how do we index data a lot faster using bulk APIs later. But for now, we'll start here, and we'll show that you can definitely see that spike from the built-in XBack monitoring, which is wonderful. Indexing latency, there's really no indexing latency. Everything's under 1 millisecond, which means there's basically no load on Elasticsearch. Now, we've never created index pattern here because, frankly, until now, we haven't had any data. So let's try something. Let's do *-fake. And hey, look, it's starting to fill out. So we want to use, this is time-bound data or time-range data. So we're going to use this post-date field as our time filter field name. This allows Kibana to know what field and know how to search for this data when we use visualization, which we're going to see for the first time right now, which I'm really excited about. So we've got these are the documents in here. So you can see that it has a CPU as a number, IO as a number, which we just added, message keyword. I'll get into all these later when we get into indexing in detail, so hang tight for now. Let's jump over to the Discover tab. So this is where we can start to find the data we indexed. So we have this built-in time range. We get more into Kibana later, so now I'm going to do this quickly. We can look at the last 4 hours, and it's a really consistent amount of documents per that time range because we faked it. But we can do cool things here. We can look at CPU, and we can say, oh, well, show me all the times or all the events where the CPU load was 65. And we can click on that search, and now look, here's some 65, blah, etc. Time ranges are auto. We can look at the actual data by clicking on here. This is not our thorough Kibana overview, but we'll get there, don't worry. So you can see this one document, index EVS, etc., is in 2017-11-23 fake. We're not doing any actual searching, so you're not getting a score. We'll talk about that when we get to the Elasticsearch API, what that means. The CPU data, the IO data, the random message we applied, the user attribute, and so we know this is a 2,559th document we loaded in Vaui.com. Hinting at Vaui.com, you should go check it out. That's all I wanted to show you today. This video wraps up our first section of this course. So now we've gotten the basics of how we installed Elasticsearch. I've kind of shown you the final picture at the end when in the first video to show you kind of how we're going to get to where we are right now. We installed Elasticsearch, we installed Kibana. Some of the networking configuration was a little tricky, especially for Kibana, because first we had the firewall, and second we had to make sure that Kibana was listening on all the interfaces, not just the local loopback. Don't forget that one. We configured networking connectivity. We set up XBack for monitoring and do a quick overall introduction of XBack. We looked at the machine learning tab, which we'll get into more later. We looked at the alerting tab. Again, we'll look at that more later. In this video, we loaded some quick data using a Python script. And then I showed you how to set up that index mapping within Kibana and how we can look at that data. So this section is done. And now next section, we get to dive deeper into Elasticsearch. So I'm really looking forward to that one. Thank you very much for watching, and I hope you enjoyed this section's videos, and on to the next one.